Hi developers! In this video we'll learn how to apply migrations to the database in CI/CD pipelines. When we create the CI/CD pipelines, we tend to include the database so that we build the database during the CI pipeline, then we deploy it during the CD pipeline, but we forget about the database. The database and the application lives together, so they should be also built and deployed together as one entity, because at the end, when we are releasing a new version of our application, that new version is a new version of the app, but also it's maybe a new schema for the database. So the interest of this video is to include the database in the CI/CD pipelines. What this means is that during the CI pipeline, we'll try to generate the SQL scripts and run those scripts during the CD pipeline. In most of the applications, this approach could be implemented using ORM like Entity Framework in .NET applications, or Hibernate for Java applications. Here when we talk about Hibernate, it's Hibernate with either Flyway or Licky Base, or Doctrine for PHP-based applications. Those ORM have the capability of detecting the changes to our entities, and then they can generate SQL scripts that map this change to the entity to a change to our database schema. They have also another option for deploying those SQL scripts to the database, because the ORM, they already connect to the database. With this option of using the ORM, we have two sub-options. The first one is letting the ORM manage the generation and the deployment of the script. So the ORM could have full control over this, over the generation and the deployment of the scripts. And we also have another sub-option, which is it's not the ORM who will generate the script, but it is rather us who will generate the script. Or we can let the ORM generate the script, but not deploying it directly to the database, but we'll take a look at that generated script, we'll test it and validate it, then we'll tell ORM, okay, now it's validated, now you can go and deploy it. Then the third option to implement this approach is using the special database projects like SSDT tools in Visual Studio. This will create a new database project which the DBA will use in order to generate, validate, and deploy the SQL scripts. With this project, we get full control over the generated SQL scripts, because we can see them, we can validate them before deploying them into our database. So now let's take a look at those different options in action using Azure DevOps. So let's start by seeing the application code that we'll take today. Here I have my web app open in Visual Studio, and my web app here uses Entity Framework. I have here a model product which contains some properties. So in each time I want to add a new property, let's say for example at first I don't have a property color, then when I add the color property, I need to add it to the object right here in C#. Then I need to tell Entity Framework that it needs to add this property to the product table. So we can do that through Entity Framework code first migrations. When we run the command enable-migrations, then Entity Framework will go and create this migrations folder for us. This migrations folder contains all the history of all the migrations that I have run for this project. At first we'll create this initial create migration, then when I wanted to add the color property, created a class, called it added color. This one will contain a description for the change that I want to do. Here I want to add a new color to the product entity. For that, here it created a method called app, which will call an entity framework object right here to call the method add column. This one will add the color column to the product table. With the app, this method actually will be run by entity framework, and under the hood, entity framework will generate the SQL query related to this operation. This means it will use the alter table SQL statement. So this is the app method. Then we have another method, which is the down method. If we want to revert back the changes made by the app method, then we need to run the down method. If the app here added a new column, then the down, it will go and drop that column. To run those migrations, we have two options. Either we go and run them using the CLI, using .NET EF migrations tools, or we can tell our application to run them automatically. So entity framework will take control over running the generated scripts. If we want to do this second option, then we need to go to the startup class. So here in my startup, I have added a call to context.database.migrate. So with this in place, and each time I have a new change to the database, entity framework will go and apply that change when my application restarts. With this option, the only thing I have to do is to generate those migrations using the command line. Then entity framework will go and deploy them to the database. Now, if we want to create the CI and CD pipelines for using this first option, then we'll have the CI pipeline looks like this one. So we'll take the source code from GitHub, then we'll go and restore, build, and test, publish the web app. And for the database, actually we don't need to do anything here because everything will be done using entity framework. And the same thing for the deployment. We just need to deploy the web app and we don't need to touch the database. So it is giving 100% of the control to entity framework. This could be an advantage if you are using small projects, but in medium and large projects, this is not an advantage. We need to get more control over the generated SQL scripts by entity framework. So let's move to the second option. Right here, I have the CI pipeline for the second option. Luckily for us here, entity framework could generate the SQL scripts and we can view those scripts. We can do that through the command line .NET EF migrations. So right here I'm using this CLI tool. .NET EF migrations scripts -o, then the name of my SQL script. With this way, entity framework will go and take a look at the migrations folder. It will pick the latest migrations, then it will read the content of the app method, then generate the scripts from that method. So at the end of the CI pipeline, we could read the content of the generated script. Because now we need this script to deploy it to the database, we'll go here and add a new publish artifact to publish the migration script so that we can get it from the CD pipeline. Moving to the CD pipeline now, we'll go and deploy the web app, but because now entity framework won't deploy the SQL script itself, it's us who will deploy that. So for that, I have added here a new task called Azure SQL Database Deployment. This task will try to connect to my SQL Azure database hosted on Azure. For that needs my admin and my password and all the credentials. Then here it needs the SQL script that I want to deploy. For that, here I'm pointing to the generated SQL script generated from the build pipeline. Now, if you have a database administrator in your team, then maybe he would prefer to use the database project using SSDT tools, because that gives him full control over the SQL scripts that will be deployed to the database. So this is how it looks like to use the database project. So it's another type of Visual Studio projects where here he can access the database, then access all the SQL files for that database. And from here he can get some really nice features like importing SQL files, creating snapshots, schema compare to compare the current version of the database to the new one, and so on. So he gets really cool features. For that, he would prefer using the database project. Now, how can we deploy these database projects during the CI and CD pipelines? First thing to understand about this type of projects is that we won't go and deploy these SQL files right here, but we go and deploy a DACPack file. When we compile or when we build this project, it will generate a DACPack file. DACPack file will contain the new schema of the database based on those SQL scripts. Later, when we want to deploy the changes or the migration, then we need to deploy the DACPack file. The DACPack file, because now it contains the full new schema of the database, it will compare that v2 schema to the old schema that is already deployed to my production database. It will detect that I have added some changes to that schema, then it will apply those differences to that database. Let's now take a look at how to build and deploy this type of projects. Here I go back to Azure DevOps, and here I have created another CI pipeline for this type of projects. Here I'm building and publishing my web app. Then I have another agent to enable parallel execution of those pipelines. I have a dedicated agent for the database project. Here I need to build the database project using MS-build in order to generate the DACPack file. Then I'll go and publish that DACPack to the drop artifacts folder. Note here I'm compiling it using MS-build, so this means that I need to run this into a Windows agent, not a Linux one. Now from the CD pipeline, we'll go and deploy the web app, and then we'll go and get the generated DACPack, then we'll deploy it to the database. How can we do that? Here we'll use again the same task we used before to deploy the SQL scripts, which is Azure SQL Database Deployment. This one will connect to my database hosted on Azure. Then it will look for the DACPack file that I have generated during the build phase. So it will take that DACPack, then it will deploy it to the database. Here I need to specify that now I want to deploy a DACPack file instead of a SQL script file. Once I have done that, my changes and the migration will be applied to my production database. This was all for this video. I hope you liked it, and I want to share with you that I have created a blog and Medium about the content of this video with more details about applying the 3 options for deploying the database to or deploying the migrations to the database.